Your sister cracks me up.
No, she does. That's
Does she always push you around like that?
yeah.
I get it. I get it. Oh. Versus. No. 0.1.
Thank you, Shelley. All right. So if we remember, well, first of all, it's discrete because there are gaps. You can't sell 1.5 cars despite the fact that our average has a decimal. If we are just looking at the values, there are gaps between the values for x. So it is a discrete variable. And then remember, you put them in your lists. So we have 0, 1, 2, and 3 for our values of x. 0.25, 0.4, 0.15, and 0.2 for the probabilities. And then we go over to calc one of our stats. Your list is list 1, your frequency is list 2. And then calculate. And so we get an average of 1.3, or our expected value or mean of x is 1.3. And like Shelley interpreted, that means typically Wilcox will sell 1.3 cars in a month. And then standard deviation, that's also given by the calculator here, so we get 1.05. So on average, the number of cars sold in a month will vary from the mean by 1.05. And then going back to A, probability that he sells at least 2 cars. So that could be 2 cars or more. So that's this one and this one, which is why she took 15 plus 20% and got 35%. Questions? Hannah.
On the test, are we going to have to round up? Because, like, 1.3 isn't actually a car, so do we just round down to 1? Or did you just answer like that?
You just answer it like that. It is weird. You can't sell 1.3 cars, but you could have an average of 1.3 because over, like, say, a year, you could average selling 0.3 of a car in a month. I don't know if that helps make sense. For the actual values, it has to be whole numbers because we can't sell half of a car. But when we find our average or standard deviation, we can have a decimal. Any other questions? All right, so today we're going to look at continuous variables. So a continuous variable has an infinite number of outcomes with no gaps. So if we define x to be the weight of a 3-year-old girl, is X continuous or discrete? Are there gaps with weights? Can you be, let's see, 3-year-olds would be around 25, 30 pounds. So 25, can you be 25.1 pounds? 25.25 pounds. So it's continuous because there are no gaps. We can have any type of decimal on the weights. Cars are not continuous because, like Hannah and I were talking about, you can't sell half a car or a quarter of a car or a third of a car. So that was discrete. This one is continuous. So the weights of 3-year-old girls follow a normal distribution with mean of 30.7 pounds and a standard deviation of 3.6 pounds. Can we make a probability distribution? So can we make a table? Remember, this is called a probability distribution. Can we make a table if the variable is continuous? No. I mean, maybe you could, but who would want to do that? It just said there's an infinite number of outcomes, so you would never stop writing because you would have to keep going forever for all the outcomes for all time. So no, I guess we really can't, even though I want to say maybe. No, we can't. We can't make a probability distribution. So what we do instead is we look at density curves. And back in chapter 2, long time ago, we learned about a special kind of density curve called the called the normal curve.
Oh, yeah.
We're going to work with normal curves here. So just a few reminders about normal curves. You're going to get really good at drawing them again. It's been a while, so they're going to look kind of wonky to begin with. But you'll get better at them, because pretty much from here on out to the end of the school year, we're going to be drawing them. Did you say that's rough? They're not, like, there are much worse things that could make you draw. So, even mine looks not perfect. Mine will get better as we do them again.
It looks absolutely perfect.
No, it doesn't. The left side's not quite the same curve as the right. But, so remember when you draw them, you're going to label them capital N so we know it's normal no matter how wonky it is. And then in parentheses, we put our mean and our standard deviation. So if I were to take these, the distribution of 3-year-old girls, I would say it's normal. It has a mean of 30.7, and what was the standard deviation? 3.6. And remember, your mean goes at the center. So that'd be 30.7. And then we labeled 3 standard deviations above and below by adding or subtracting the standard deviation. So let's see, 30.7. I should be able to do that in my head. Come on, Amber. It's 34.3. And then if I add 3.6 again, that'd be 37.9. That'd be 40.9, 41 and a half. And subtract, that'd be 27.1, 24.1, so 23.5, 20.5, so 19.9. Is it coming back to you? Total area under the curve is equal to 1. So if we want to find the probability that x is less than 28, what we do is we find the area under the curve. And we showed that by drawing a line at our boundary point, which in this case would be 28. So I'm going to say around here. That's 28. And we're looking at less than or equal to 28. So we're looking at the left side of our boundary. Now, the probability that x is less than or equal to 28 is equal to the probability that x is less than 28. So less than or equal to 28, less than 28. They're going to be the same probability, because the probability that x equals 28 is 0. Because the probabilities are found by finding an area, and x equals 28 is a line. Lines do not have area because they're not two-dimensional. Area is found by taking two things and multiplying them, length times width. So if we have a line does not have two dimensions. It's only got length. So they end up being the same. And then, of course, remember, not all density curves are normal curves. We're going to focus on normal curves. Anybody happen to remember the calculator function that's going to get us our answer? So was that you? It is normal CDF. Good memory, Calvin. So we're going to use normal CDF. And remember, the newer calculators will prompt you, the older ones do not, but the information is your lower bound, upper bound, mean, and standard deviation. So if we want to find the probability that x is less than or equal to 28, we use a really small number for our lower bound, like -1e to the 99, or you can just type in -100,000, up to you. The upper bound is 28, our mean is 30.7, and our standard deviation is 3.6. Do you remember how I get there, Calvin? How? Where do we press? He's making me so happy, sorry. Somebody remembered something I taught. It is second bars. Who said that? Was that you, Hannah? No, it's not you. All right. So you're going to hit second vars, which is right next to clear. And it gives you this menu. We're going to work with normal CDF like Calvin reminded us. So mine prompts me, and it also put my lower bound as the really small number.
Can we do that again?
Yes.
What do you put?
Second vars, which is right next to clear. And then number 2, normal CDF. Older calculators will not prompt you. That's why I reminded you it's the lower, upper, mean, standard deviation. Mine already put the lower in there for me, but let's say it's not in there. Just to remind you how to get that E. And the fact that the negative button is this button down here. Do not use the subtraction button. The calculator will get angry and say error. So you're going to hit -1, and then, nope, no. There's like 3 ways to get E on here, and they all mean something different. The E we want is this EE above 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5. 0.5 in the dark blue above the comma. So you're going to hit second comma. And that tells the calculator we want scientific notation. So really we're multiplying by 10 to the 99th power. And then my upper bound is 28. My mean is 30.7. And my standard deviation is 3.6. And then I'm going to choose paste, and it puts it into my home screen for me. And then I hit enter, and we get our probability of 0.2266. We're going to be doing lots of normal CDFs today. Lots of them.
This isn't as bad as some of the other stuff that you taught us.
I know, right? Calvin.
On the board, I hit 45.
Yeah.
Did he use this?
Nothing yet. About 45.
Really?
Yeah.
Oh, I need to adjust that then. 45. Thanks for letting me know, because that shouldn't have been there. But I will tell you I changed the order of 2 of my lessons this year. And it was last time and this time, so I assumed the homework didn't use this. But I'll adjust that for next year, sorry. I apologize. No wonder you remembered normal CDF. Alright, so we're going to remind ourselves of another thing back from chapter 2. So down below, suppose that intelligence scores, or IQs, are normally distributed with mean of 100 and a standard deviation of 15. We're going to use the 68, 95, 99.7 rule to figure out the percentile for a person who scored 130. And we're also going to show our picture. So our picture is just our normal curve. Anybody remember the 68, 95, 99.7 rule and what it tells us? Alex?
68 is 1 standard deviation away from 95 is 2 standard deviations away from 97 is 3.
Thank you, sir. So 68% of our data is within plus or minus 1%. Excuse me, I can't speak. 68% is within plus or minus 1 standard deviation of mean. %, is within plus or minus 2 standard deviations. And then, excuse me, 99.7% of our data falls within plus or minus 3 standard deviations. Normal curves are symmetric. So our mean is going to be 100, going down the center. And then I have 1 standard deviation above the mean, would be 115. 1 standard deviation below is 85. And between those two numbers is 68% of my data. Then I'm going to go another standard deviation above, which is 130. And another one below, 85, that'd be 70. Between those two numbers is 95% of my data. And then 3 standard deviations above would be 145, and 3 below would be 60, 55. And between those two numbers is 99.7% of my data. we want to know what percentile somebody who scores 130 is at. Percentile means what? Is that the percent below or percent above? Below. So we want to know what percent is below a score of 130. So 130 is my second standard deviation above the mean. And I want to figure out what percent is below that. So using our 68, 95, 99.7 rule, I know 130 down to 70 is 95% of my data, which leaves what percent for my two sides? I have 95 between the two. What percent is on the outside? 5. And because of symmetry, I know what percent is on each side. 2.5. So I know there's 2.5 here and 2.5 below 70. That was a really bad bracket. I apologize. So 130 only has 2.5% above it, which means I'm at the 97.5 percentile. Sorry, didn't realize my paper was sideways. Well, not sideways, but angled. Questions before we look at the next problem? Sam.
Why is that only 2.5? Is that 130? Wouldn't that be like when it was at 145?
So between 70 and 130 is 95% of my data, which means I have 5% for these two tails, and symmetry tells me it's perfectly in half. So 2.5% below 70, 2.5% above 130. Alex?
So then you go, oh, okay.
Good? Calvin?
I forgot why. Why is it 95%?
Why? So, yeah, because, so they looked at a bunch of distributions and they transformed them all to the standard normal distribution, meaning you have a mean of 0 and a standard deviation of 1. And they just found that they all follow the same pattern. And so it's a rule that we just can follow. Actually, if I'm being technical, they're lying to you. They round. It's not exactly 95%. I can't remember off the top of my head what it is, but it's not perfectly 95%. But if they said it was 68%, 94.77%, and 99.7%, it wouldn't be as easy to memorize. So they just rounded the middle one to 95 and said, I actually think 68 is not exact. I could look. I don't remember off the top of my head. But it's a nice introduction. And then once you learn the calculator function, you can find the actual ones. I could right here figure it out if I did. Let's see, if we went from 70 to 130, we have a mean of 100 and a standard deviation of 15. See, it's 95.45. It's not exactly 95%, but it's easier to just tell you 95%. Did I answer your question? Okay. All right, so the next question says, what percent of people score below 90? We're going to draw our picture. We're going to give a z-score calculation. And then in the book, it's gonna say use table A. You don't need to use table A because it's a lot easier to use calculator. I showed you table A back in chapter 2, but the calculator does everything table A does, so there's no point in doing it in the old school way. Because if you take the AP exam, you're going to have your calculators, and it takes a lot less time to use a calculator. So we're going to start with drawing our picture. Yes, it is the exact same normal curve with the exact same numbers, but we're going to shade a different area. So we do draw a new normal curve. Don't forget to label. Capital N has mean of 100, standard deviation of 15. So we want to know how many, not how many, but the percent of people that score below 90. So I'm going to estimate 90 is here-ish. So we're looking at this area here. Now this one also asks you to do a z-score calculation. And that's going to be important for the rest of the school year as well. So we need to remember how to find z-scores. Anybody remember that one? Nobody? That would tell us, yes, the z-score if we knew the percent under the curve, which we will do in a minute. But for now, I just want to know the formula. Nate?
X minus mean over the standard deviation.
Your observation minus the mean divided by the standard deviation. Thank you, sir. So our observation, we're interested in a score of 90. It's got a mean of 100 and a standard deviation of 15. So we get negative 0.6666666. Usually z-scores go to 2 decimals, so I'm just going to round to 6.7. It's negative because my observation is below the mean. It's not quite one standard deviation below the mean. One standard deviation would be 85. So that's why we're not quite to 1. I'm 2/3 of the way to that standard deviation below the mean. Remember, that's what z-scores tell you, how many standard deviations above or below the mean you are. And then here on 3, I redo problem 2 using the calculator function. So I'm going to do the calculator function down here. It's normal CDF, like Calvin reminded us. Our lower bound for that area that we shaded is just a really small number. So -1 e to the 99. The upper bound is 90, mean is 100, standard deviation of 15. And some of you are writing that so that when you do the homework, you remember what to put in there. But when you do these problems on the AP exam, you need to write all that out. Otherwise, they're not going to give you credit if you just put in the answer. You have to have the calculator function with all the numbers you type in written down to get credit. So when we go to second bars, number 2, really small number, We're looking at 90 for the upper bound. Mean is 100, standard deviation of 15. So we get 0.25, 0.25. I cannot speak today. I put a point in there twice. 0.2525. Sorry. With your probabilities, go to 4 decimals. If we were to actually use the old school way of using table A goes to 4 decimals. So we go to 4 decimals with our answers from the calculator. Questions? All right, so on 4, we're going to go backwards, which is what Zach was reminding us. See, I really cannot speak. Reminding us of when he said inverse norm. So we want to find a score that puts the person at the 99th percentile. We're going to draw our picture, and we're going to find the z-score, and then we're going to use our calculator to find the answer. So still not using table A. Remember, the book is going to say use table A. Use your calculator. It's much quicker and technically more exact because table A does some rounding. So we're going to draw our picture. Still a normal curve with mean of 100, standard deviation of 15. Now, we want to, sorry. There we go. We want to find the 99th percentile, which that whole 68, 95, 99.7 rule can help me kind of estimate where it is. If I get to 145, there's only 0.3 above that, 0.15 above it. So that's too far. So I'm going to be somewhere in between 130 and 145. I don't know exactly where, but I know it's going to be in between those two. And then when I shade it, I'm going to have 99% being shaded. And Zach, when I said z-score, he remembered the calculator function that helps us find a z-score. What is it, Zach? It is inverse norm. So when we want to find a z-score, we're going to use inverse norm. Now, z-scores are based on the standard normal distribution. So you're going to work with a mean of 0 and a standard deviation of 1. So we're going to do inverse norm. And I guess over here I should remind you, inverse norm has 3 things. If you're working with the old calculator that it asks for, it wants the area, the mean, and the standard deviation. So we have 99% for our area. And to find the z-score, we're going to use a mean of 0 and a standard deviation of 1. Some of the newer calculators will ask which side the tail is on. We're shading to the left, so you would say left. Inverse norm is in the same place as normal CDF, so we go second bars. It's just number 3 in that menu. Yeah, menu is the right word, right? Area 0.99, mean 0, standard deviation 1, see, this is what I was talking about. If it asks tail, that means what side are you shading? We're shading to the left. So I'm going to leave it as left. A lot of them don't ask though. Some of the newer ones don't even ask. So we get 2.33 when I round. So I have a z-score of 2.33. And now we're going to find the actual IQ score for the 99th percentile. It's the same calculator function. We're going to do inverse norm. Still looking at 0.99 for the area, but now we use the mean of 100, standard deviation of 15. And that'll give us the IQ score for somebody at the 99th percentile.
Why do we just do the 0 and 1 then?
That was to find the z-score.
So what are we doing now then?
We're finding the actual IQ score. So see, the z-score is 2.3, and I drew my boundary line here, and that's 1, 2, more than 2 standard deviations above the mean. So the z-score tells me it's really 2.3 standard deviations above the mean. Now with this one, when I use 115, I'm going to find the actual IQ score. What did I do wrong? Oh, I don't know how I got log in front of my inverse norm. I was like, that should not say that. Sorry. All right, let's just clear out of there. So we get 134.9 when I round. So somebody with an IQ score of 134.9 would score at the 99th percentile. Any questions before we flip to the next problem? Hannah?
So then what is it when it's like just the top shading?
You mean here?
Yeah.
It might say something like what IQ score puts a person in the top 1%. Which if your calculator like mine asks the tail, I could say 0.01 for the area, and then it's the top 1%, so my tail's on the right. It'll give me the same IQ score. If your calculator doesn't ask about the tail, if it's what scores in the top 1%, you would do 100 minus 1 and put 99% in there. Anna?
I already explained this, but why do we plan like for her to do this? Like, I don't, like, why do we need to insert the number 5 question?
You don't need the z-score to do the number 5 question, but z-scores are something they can ask you about with any questions, so it's just a good reminder how to find them.
Okay, so you don't actually need it.
No.
Okay.
But like when we get to chapters 9 and 10, it'll just become part of doing every problem, is you find the z-score and then you find the probability. If you plan on taking the AP exam, a lot of times, so they do, I can't remember what it's called, when you get 0 credit, probably just incorrect, but they have incorrect, partial, and full credit. So a lot of times to get the full credit, you have to give the z-score and the actual answer, because what, at least what I've been told when I've gone to trainings, for kids who just give the answer, they're assuming kids just memorized calculator steps and they're not actually understanding the statistics. So by requiring them to show the z-score, which yes is just another calculator thing to punch in, they're assuming that they understand a little more about the statistics behind the answer. So to get full credit on a lot of AP questions, you have to do both. So I'm going to start building both in there so it becomes habit instead of like in May being like, oh, by the way, you need to show both. I just want to make it a habit so that you do it automatically. Any other questions? Hayden's over here laughing at what his friends are texting him. He looked so bored 2 minutes ago, and now he's got a giant smile on his face. Your friends must be so cool. He's like, I'm not going to answer that. I'm picking on you, Hayden. I don't care. You can text your friends if you want. I know I can be boring some days. I try to be fun sometimes too. Alright, so this time it says the normal sorry, it just threw me off. It started with numbers and not the situation. The normal distribution with a mean of 6.8 and a standard deviation of 1.6 is a good description of the Iowa Test of Basic Skills vocabulary scores of 7th grade students in Gary, Indiana. We're going to call the score of a randomly chosen student X for short. So we want to find the probability that X is greater than or equal to 9, and then we're going to interpret the result. So part A is draw a picture to represent the situation, find the z-score, use table A. We're not going to use table A, we're just going to use our calculator. So for part A, we're going to draw the picture, find the z-score. Part B, we'll use the calculator. And then part C, you guys are going to try on your own. See, I'm putting Hayden back to sleep. He wore pajamas. He's like, aren't you the one who told me that you get the best sleep in the desks?
Yeah.
I don't get that. They're so uncomfortable. Alright, it's normal. We have 6.8 at the center. Seven 8.4, so that'd be 9, 10, 11.6, 5.8, 5.2, 4.2, 3.6, and then 2. So we're working with, kind of got hidden up here in the paragraph, but we're working with the probability X is greater than or equal to 9. So that's the value we're interested in, which I'm going to say is around there. Now this time it's greater than, so we're working with shading the area to the right. First thing we're going to do is find the z-score. And Nate reminded us of the formula. Our observation minus the mean divided by standard deviation. So here that's 9 minus 6.8 divided by 1.6. So we have a z-score of 1 point. I really suck at this today. I put an extra 1 in there for some reason. I don't know what's wrong with me. And then part B, we're going to use the calculator to find the answer. So this is the first time today that we're working with shading to the right. So on this one, our lower bound is 9. And our upper bound is going to be a big number. So I'm going to do 1e to the 99. Mean is 6.8, standard deviation of 1.6. So we get 0.0846. 0.0846. And then up here it also told us to interpret. So we would say about 8.46% of 7th grade students in Gary, Indiana get a score of 9 or higher on the Iowa test of basic skills. By the way, for some reason the students in Indiana actually take the Iowa test. Don't ask me why. This is real data. I don't just make things up.
How do you type in the 1E99?
To get the E, you're gonna hit second comma, and it should give you that small uppercase E. So for our interpretation, about 8.46% of 7th graders in Gary, Indiana. Was it, I feel like there's some movie set in Gary, Indiana. Gary, Indiana, score 9 or higher. And I'm gonna abbreviate because Iowa test of basic skills has an abbreviation on the ITSB. Now that I've read that, I'm wondering if I mixed up and it should be BS when I type that. Make more sense. Iowa test of basic skills. I might have transposed the S and the B, not that that part really matters. Questions? I don't know why the Indiana kids take the Iowa test, Hannah.
How come you have to leave the decimal?
How come I moved the decimal from there to there? Because, I don't know. I suppose you could say about 0.0846. That's a proportion when it's given as a decimal. And I guess interpreting, saying a percent makes more sense. And so you move your decimal 2 to the right or multiply by 100. You could leave it as a proportion. It just, at least in my head, grammatically, it makes it harder to write a sentence. You could say about 0.0846 proportion of, I don't know. That's why I changed it to a percent, because my brain doesn't work that way. I'm sure there's some way you could say it with proportion. Nate, he's going to help me out here.
The proportion of 7th graders in Gary, Indiana that score a 9 or higher on the ITSB is 0.0846.
There you go. And then you don't have to move the decimal. Thank you. I knew it could be done. My brain just was not working in English. Any other questions? All right, you guys are going to do part C. Find the probability that x is less than or equal to 4. Draw your picture, find the z-score. Don't worry about the table A part. And then get the answer on the calculator. If you feel like it, actually interpret the result. Hayden? Yeah. I know.
Man.
Yes. I really don't know why they take the Iowa test of basic skills. It always throws me every year. But they do.
I just put the subtraction and then use the calculator and faster. Because otherwise it follows paragraphs and does division first.
I'm loving these super rounded curves that are just like a rainbow, actual bell shape. Hayden,
Yo.
nice rainbow.
Yeah,
I said if you feel like it, you can.
okay, well, I just,
That's good.
Yep. I didn't see that at first, sorry. Yes. And we're back. You want to do it on the board?
So I'm,
Go, now, go. Go, now, go.
do you want me to draw the whole graph on that stage?
Yeah.
it's on over, what's on the after and then you
Well, the reason why I said check on the calculator was because I used to show through the calculator and then I realized a lot of extra work.
Sorry, I was about to say. It also, just for this one, you know, it says that it's like 3.5 in this area. Isn't it actually like, 3.5 since it's 4.7?
Yeah, it's not, so we use this tool to kind of tease out the idea. But it's not exactly.
Is the up and down and actually like different?
Right, under the curve is so under.
Wait, did you do
Anytime, like you're gonna give an answer, like you're gonna say using this.
Yeah, negative one.
Otherwise,
And then
use the
what did you
calculator to
use?
get an answer.
Upper? That says
So,
it's
oh,
word.
they actually did.
Because it says-
Can I see it?
That is supposed to be less or less than or equal to 2.
Using this.
Okay, I see it.
Otherwise, use your
I think that's it.
Oh, wait, which was supposed to be okay.
Does that make sense?
Oh, wait, what? Oh, wait. Oh, wait, I'm in the one. My bad.
I just wanted to make sure people were right.
Oh.
Thank you, Noah.
Maybe that was good.
All right, so we get a z-score of negative 1.75, and when we put in the calculator, we get 0.04 or 4% of the kids get a test score of 4 or less. Questions? If you haven't already, go ahead and try the problem below about the length of pregnancies. No, and there's a better pencil sharpener over here.
I got this one to work a
Well,
little
that was
bit.
insane though.
That one's good.
It's really good. It's like the best one in the school.
Really?
Yeah.
Oh, I have the best pencil sharpener in the school. Go me.
Yeah, it's pretty goddamn.
It's good.
Seriously?
No, I swear to you, that's not me. Like, it was one of the lazy states. She said training.
Oh, that cracks me up.
It's not my handwriting.
I know it's not your handwriting. I don't know. That's not how, if somebody said your name, that's not how I would think to spell it. I would think you, man. But that's just me. I am special. I have the best pencil sharpener in the school. Yeah, he didn't just pull me through.
No. Oh, wait, no, you're trying to find it.
They're supposed to get better, right?
I know. Oh. We don't think about it.
Then it got a little more bell-shaped and nope.
I was like, you know what, no, thanks.
Is this just any different? Is this just
Yeah. Why are they doing this? Which I explained on the, like, when I first talked about it, I explained why. No,
Oh, yeah, because you're not looking.
you just don't wanna do it. Okay.
Yeah, they're up now to 240.
If it's less than 240, we just say 230 for the other one. Or 230. This is not equal.
Say that again.
So like for the
On
numbers.
B.
Yeah.
Uh-huh.
You said at 230.
Yeah.
Oh. Oh.
I have an answer. Yeah, 240 should be your lower bound.
What?
Because his X is greater than or equal to 240. See, it's your lower bound where you shaded. 240 is the lower bound of the shading.
Then why is it not?
Yeah. What do you mean, why is it in the upper? When you wrote it in the upper, it should be the, it should be your lower bound. Right, so you shaded greater than 240, so of the shaded area, what's the lower bound?
Oh, that's what it's.
How do you find the Z?
Okay,
It always throws me off.
So they usually work for 8 weeks.
Yeah, that's average, that's typical.
What? 16 weeks early?
So, a woman is, it's 40 weeks, it's full term, and 40 times 7 is 280. So if you're 2 weeks early, 280 minus 14 is 266, which is the average. It always just throws me off. Why don't they just say that then 38 weeks is full term?
You know what the hell?
It always throws me off.
There you go.
So, what?
I know, that drives me insane too.
It's basically the
So
same thing
they've
as
been
A.
pregnant 3 times. Actually, my daughter came 2 weeks early, exactly 2 weeks early.
It
Ours
equals-
average.
If it equals that,
Another
which is
2
basically
weeks.
the same thing as this. Right? So it's basically
Wait,
the
does that
same.
matter?
I'm assuming it is. I didn't ask you the difference scores, so I don't have it on me.
I got, what you get?
Yeah, so I think I know now.
Yeah, you guys got this.
Oh, wait.
2.5 or something?
It's because you,
2.5.
it's because you put the 199 is the lower, and the lower should be 240.
Is that lower?
I think so.
Yeah. I was just making sure people were paying attention to me earlier. in
I got
the
one.
So, this
Not
was,
exactly one.
oh,
For what?
Oh, it's not.
It is.
What'd you get?
For what?
The number.
You guys did good.
Probability of
What?
Hold up, hold up.
How did you get that number?
Probability.
For this? How did you get?
why did you find this?
Is 28 because
Yeah, the way I pressed it in, I got it. That was-
Wait, so did,
probability.
When I pressed it in, I just had the
what
number.
did you get? And
It's 266 days, not 166.
Okay, you ready?
see, how'd you even read it? You
Now,
knew
we
exactly
closed it, it's the exact same earlier, literally expressed.
Up here. Honestly, that question was.
Oh, yeah, they're the same. If you four.
Yeah, that was. Oh, I remember. No.
It's an algebra and then. Oh,
So that's saying that you're gonna find the top,
So you just bring it back?
top one. You don't have to do greater than.
no, that's not, okay.
Find the top.
Yeah,
three.
upper
Percent
bound.
pregnant.
Is 1,899 and the lower bound is
Will you look on the board for me, please?
Yeah.
Okay, most of you have moved on to part C, which is awesome. Amelia's gonna put the answers to A and B up for us, so that you guys can make sure you're on the right track. Is your calculator I was copy? So I figured that out. Are you taking the Oh, I was gonna say you would have to write. But since not.
I know that it's like the top 10%, so I just want to look at maybe the percent on. So it's like,
the carrier shit confuses you just that way, but,
Does that mean greater than?
yeah. So, you're trying to, so X,
We don't use,
Gotcha. Thank you.
nope. I mean, we.
Okay, I get it.
Times it, add it. Times a line.
what, the middle? Okay. Are you serious right now?
No,
That's ridiculous.
What's ridiculous?
Scooby-Doo. He's pretty
fun stuff.
You were. My contact.
Oh, yes.
I got
All right.
Oh yeah.
Some of you went to a few more decimals. I think I saw 0.9479.
Oh. 266 minus 16 isn't 240.
No, it's not. Alex?
I got the last one.
Oh, you did?
That makes sense.
What did you get?
Yeah. No, it's the 80% carbs is the top.
I got 279.
So, yeah.
279?
Yeah.
That is correct.
I disagree.
That is correct, yeah. Who said I disagree?
That was me, but that's just because I like 252 and I don't get why.
So this is saying top 20%.
Oh, 0.8.
So you need to use 0.8 for your area unless your calculator asks about the tail.
Okay.
So you would do inverse norm, 0.8, 266, and 16, which gives you 279.47 days.
We didn't even get to watch the announcement.
We never watch the announcements. Come on.
Shame.
And when I do put them on, Zach, you all ignore them. Bye.